Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.8, Problem 14. This is Section 2.8, Problem number 14. It says complete the computation. We have 5 over 18 plus 7 over 24. Now, this problem has two different denominators, so we have to write it in a form where the denominators will match. So when I have to do that, I like writing the problem vertically a little bit better. So I'll write the first fraction, 5 over 18, and below it I'll write 7 over 24. Put a line, keep it a plus, because it is a plus in the original question, because some of them are subtract, right? So now, when I have different denominators, what I like to do is start with the larger denominator and ask myself, will the smaller denominator divide into it evenly? So in this case, the larger denominator is 24. Will 18 go into 24 evenly? It will not. Then take the larger denominator and double it. So if I double 24, I get 48. Will 18 go into 48 evenly? It does not. So take the large denominator, triple it. 3 times 24 is 72. Now I know that just because 24 hours in a day, I know 3 days is 72 hours. Let's say you don't remember that. Triple it, so I'll go 24 times 3. 3 times 4 is 12. Write the 2, carry the 1. 3 times 2 is 6. 6 plus the 1 more that you carried is 70. This is 72. Now, so I know for sure that 24 is going to go into 72 evenly. It's going to go in 3 times. That's what I've got. The question is, will 18 go into 72 evenly? And it will. I know it'll go in 4 times, because if I double it as 36, double it again, which would be times 4 is 72. Let's say you don't see that right away off the top of your head. You just divide it in. So I claim it's times 4. So 4 times 8 is 32, carry the 3, 4 times 1 is 4, plus the 3 more that I carried, 72, it goes in evenly. Now, your other option is to find the LCM of both denominators by doing the prime factorization, and that works, and it'll work every time, but I feel that that takes longer, it's more tedious. That's the explanation that most math books give. I like to just take the larger denominator, see if the other denominator goes in evenly. If it doesn't, double it, then triple it, quadruple it. Keep going, making it a little bigger until the other denominator divides in evenly. So 72 will work as a common denominator, lowest common denominator. So I will write an equivalent fraction next to each of the original fractions with a denominator of 72, and now I need to figure out what the numerator will be to make those fractions equivalent. So 5 over 18. 18 times some value is 72. Well, because I did the work, I know that times some value is 4 times 4. 18 times 4 is 72. So now the numerator of 5 times that same value will give me my new numerator. So my numerator 5 times the 4 will make a 20. 20 over 72 is equivalent to 5 over 18. Now let's do the same process with the other fraction, the 7 over 24. So again, 24 times some value becomes 72. It's times 3. And again, I have that work over here to prove that. So that times 3 has to be applied to the numerator also. 7 times that same amount of 3 will be 21. Now I can just go ahead and combine the numerators. I have a common denominator. This problem is an addition, so I'll just add the numerators together. So the denominator for my answer will be 72. And if I add the numerators, 20 plus 21 more is 41. So I get a result of 41 over 72. Now you want to ask yourself, can I reduce that? Are there any values that divide into both 41 and 72 evenly? And it turns out that there are not. You can see that they're not even, so 2 won't work. Will 3 work? 3 goes into 72 evenly. And I can check that because 7 plus 2 is 9. The sum of the digits is 9. 3 goes into 9. It'll go into 72. But for the numerator, 41, 4 plus 1 is 5. 3 doesn't go into 5. It won't go into 41. And you can see 5 won't work. You can try a lot of different things, and you won't find anything that divides into both of them evenly. So the final answer is 41 over 72.